In this demo, we will look at how confidential containers protects application memory. But before we do that, let's look at Kubernetes components at a higher level. This side, you have Kubernetes control plane, the scheduler, API server, controller manager, etc. And these are a bunch of nodes. Each node has an agent called kubelet, which gets instruction from API server to start a pod. So going forward, we'll zoom into this node, look at the instructions or interaction that kubelet has with containerd and so forth. Let's look at a typical application or pod deployment using runc. This is a regular hardware or any machine that you can think of, which has kubelet running. Kubelet gets an instruction to deploy a pod, which it hands over to containerd or CRIO. Containerd then uses runc to start a pod. Now on to the cluster. Here is a single node QVDM based cluster. We will deploy a sample application. This is a basic curl app which downloads some secret stored in remote location and stores that value of that secret in an environment variable. Let's look at the value of that secret from remote location. Now this is a typical deployment of that curl application. Here we are outputting that we are downloading secret, doing a curl, storing it in env and then sleeping. Let's deploy this. Once it is deployed, you can see it's running. We don't see any runtime class information. And from the logs, we can see it outputted the thing. It showed curl output and now it's sleeping. So since it's sleeping, we can look for application which says sleep. We get the PID of that application, store it in an env var so that we can do a core dump and look at the ASCII representation of that core dump file, grep for the secret that we are hoping to look at. Now let's look at the pod deployment using Kata runtime. So here we have a virtualization enabled hardware which can start VMs. The kubelet, as before, gets a request from API server to start a pod, which then talks to containerd. Containerd in this case talks to something called as Kata runtime. Previously it was runc. Kata runtime talks to a virtualization software like KVM. KVM is responsible for creating VMs on this worker machine. Once the VM starts, Kata runtime then talks to Kata agent. Kata agent here is the PID1 of this VM. The image is downloaded, and then the Kata agent uses runc to start pods as runc would do on a worker node. And a Kubernetes pod has started. Here we can see that there are pods deployed in confidential container system. It is deployed by operator, which creates these runtime classes. We will focus on two runtime classes, Kata QEMU and Kata SNP. So let's look at the deployment using Kata. Here we have added runtime class name Kata QEMU, and it's the same thing that we're doing as before. Once we deploy it, we can see that the pods are created. The pod is created, and it has a runtime class name Kata QEMU. You can see at the logs that it downloaded a secret and now it's sleeping. So let's look at the processes. So this time around, we did not look for a sleep process. We looked for a QEMU process because this is running in a pod, in a VM. The pod is running in a VM. Let's get the PID. store it in an env and do the core dump of this process. So once we get the core dump file, we look at the ASCII representation of the core dump file and grep for the secret we are hoping to look for. We can see we can see by reading memory, it is available twice and also the env is available. Now let's look at the same deployment but using Kata confidential containers. So here we have a hardware or a worker node which has special processor, the AMD's SEV SNP or Intel's TDX. This hardware is capable of bringing up a VM with encrypted memory. So it's the same again. Kubelet gets a request from API server, which then talks to containerd, which then talks to Kata runtime. Again, it talks to KVM in this case to create a virtual machine. The Linux guest is created. We still have Kata agent like before. The image download is processed, but this time around we also have something called as confidential data hub and attestation agent. These are the components responsible for doing remote attestation. So here we are downloading an encrypted image. So in the attestation process, we will the confidential data hub and attestation agent will talk to relying party and get the decryption key for the container image. Once the attestation is successful and the key is downloaded, the image download can process now. The image is downloaded and decrypted and made available for the Kubernetes for a Kubernetes pod to start. Here again, the runc is used to start the pod. The machine that we looked at before is AMD SEV SNP enabled. Let's look at the deployment, but this time we are using Kata QEMU SNP runtime class. It is again doing the same thing, downloading secret, storing it in env. So let's deploy this. Once it is deployed, we can see the pod is up and running, and we can look at the runtime class name Kata QEMU SNP that we defined earlier. We can see that the logs are still there, uh, and we'll grep for the process QEMU. So if we look at the process QEMU, we'll get the PID of this application. We'll store it in the env or PID. Let's do a core dump of this VM and look at the ASCII representation of this core dump. And while looking at it, we grep for the secret that we are hoping to find. This takes some time because it's a big VM and it exits because there was no secret. The memory was encrypted. In this demo, we saw how an application which is started using runc and Kata, even though Kata has better isolation than runc, we can still do memory dump of that pod and see what's really going on. But when we started with Kata confidential containers and do a memory dump, we do not find anything, which means the memory was encrypted and protected.